Hello, namaskar bachcho, good evening everyone. So how many students are there in the session? Please mark your attendance so that we can start the session. Okay. सर एक डाउट है इन सेकेंड ऑर्डर सर्किट अंडरडैम्प्ड सिस्टम विद वोल्टेज सोर्स अंडरडैम्प्ड. Okay, the value oscillates between the steady state value and this value can go above the steady state, which is not possible. It can go above the steady state ना, underdamped है ना, underdamped है ना. It's underdamped, na? So the output goes like this. It goes above, then down, then it will follow like this, right? Input is unit step. Input is unit step. Underdamped means like this only. Okay, so let's start the session and we'll be doing a lot of questions today on communication. So let's start the session and we'll do lot of questions. So let's start. Okay. So let's try to do all the questions, dosto. Let's have the session. Let's do the session in the exam mode. Okay, let's do the session in the exam mode. In exam also we have maximum 3 minutes for a question. So let's start doing this. So suppose this question is given, the angle modulated signal is given. Okay, we have to find out the maximum frequency deviation. We can see that the phi t is equals to 2 pi fct plus 4 cos 1000 pi t plus 3 sin 1000 pi t. Okay, so the frequency f will be 1 upon 2 pi d phi by dt. This will be fc plus 1 upon 2 pi and this will come out to be 4 into 500 and cos will become sine and this will become 3 into 500. This will become cos. And they are of same frequency, right? They are of same frequency. The frequency is same. The frequency is same. So what will be the maximum deviation? We can see that this is delta f. And since sine and cos are of same frequency, the maximum value will be under root of 2000 square plus 1500 square. Is it fine? Because sine and cos are of same frequency, so the maximum value will be under root of a square plus b square. Okay, so what is the answer? What is the answer? Can anyone tell me? Under root of a square plus b square, that is 4 into 500 whole square. So this will come out to be 2500. Please check everyone. 2500 hertz, 2.5 kilohertz. So in maximum 2 minutes the answer should be there. In maximum 2 minutes the answer should be there. Not more than 2 minutes is required for solving this question. So all of you are able to do this question. It's a very simple one. So all of you are able to do it. Okay, let's move on to the next one. Now, given that xt is equals to is a wide sense stationary random process, yt equals to 4 times of x of at, Which of the following is correct? Okay, so we can say that yt is equals to (4x of at), yt plus tau, whole expectation will be 4x at plus a tau. Okay, and now this will be 4 and 4 16, and the time gap between these two will be a tau. Okay, so we can say that r y tau okay, क्या होगा दोस्तों आंसर? What will be the answer? So the answer will be this. Not more than 1.5 minutes or 90 seconds should be required for this question. If you are a good student, studying well, and expected to perform well in this exam, then not more than 90 seconds is required to solve this question. Just check all of you are able to do it or not. Are you able to do it? I'm not getting anyone answer. I'm not getting answer from anyone. Okay, good. So this is done. Let's move on to the next question. Okay, a good question. Now, we have a binary PSK transmitter. We have a binary PSK transmitter which actually transmit S1T and S2T, 0 to capital T, 0 to capital T. We have these two signals, bit 0 and bit 1. Okay, S1T is A cos omega CT and S2T is minus A cos omega CT, right? The correlator receiver at the local carrier wave is this. At the correlator receiver, we have the local carrier wave, which is this. Instead of A cos omega CT, due to pure synchronization, A square T by N naught is given as 20 and phi is given as 30 degree. The probability of error is, we have to solve this question. Thank you, Anmol. Thank you very much. But sir, if source is present, then how the capacitor voltage can be more than the source voltage? Voltage goes to steady state. It can be, right? It can be. It's a circuit property. So, I have to check the question with what you are referring to. Please, if you can, then share the question on Telegram. We can discuss it there. Okay. Now let's try to solve this question. So in this case, we are sending this. The noise is getting added, obviously the AWGN noise, PSD N0 by 2 or 𝐴 by 2. At the receiver, we have a correlated receiver. I hope all of you remember the correlated receiver. Correlated receiver is A cos of omega CT plus phi. And then we have an integrator 0 to TB dt. Now, if we multiply this term with this and then we integrate, so we can see that this term multiplying with this, so cos and cos getting multiplied, cos A cos B is cos A plus B and cos A minus B. Cos A plus B will be a high frequency term, A minus will give you cos phi. So here we get plus minus A squared T by 2 to cos phi, okay. And we get a random variable because noise is also getting added, multiplied with this and integrated. So we can get a random variable Z with obviously zero mean and variance is equals to N0 by 2 or 𝐴 by 2 multiplied by the energy of this pulse. Now energy of this pulse is A squared TB by 2. Okay, A squared TB by 2. So we can see that, I hope all of you remember these steps. These are very important steps, very important, and this type of question can be expected in a GATE exam. So we can see that okay, we have a Gaussian here. So we can see that the probability of error is Q of the complete distance by 2 . Okay, so complete distance is A squared TB cos phi by 2 is A squared TB by cos phi by 2 divided by under root of the noise variance, so N0 by 2 A squared TB by 2. We can simply take it inside the bracket, will be Q under root of A squared TB by N0 and cos phi outside the bracket. So now A squared TB by N0 is given as 20. So we can take it as this. This will come out to be Q of under root of 20 multiplied by cos phi. Now what is cos phi here? Cos phi. Phi is 60 degree. Cos phi, sorry, phi is 30 degree. This is root 3 by 2. Will be under root 30. Okay. Okay, root 3 by 2. 2 is outside this under root, right? Sorry for this mistake. Under root 3 by 2. This will come out to be Q of under root of 3 by 4. This will come out to be Q of under root 15. Please check all of you are able to do it or not. Q of under root 15. Is anyone there in this session who has done this question? Is anyone there in this session who has done this question? A very beautiful question, including the concept of correlator receiver. Please check. Please check all of you are able to do it. हेलो, ठीक है अंकल, पहुंच जाएंगे, पहुंच जाएंगे अंकल। मेरी उनसे बात हुई थी, उन्होंने टाइम नहीं बताया था। ठीक है अंकल, हो जाएगा अंकल। जी अंकल जी, जी अंकल जी, थैंक यू अंकल। Okay. So the bandwidth efficiency of M-ary PSK improves as M increases. So this is correct, because we can say that what is the bandwidth efficiency? What is the bandwidth of M-ary PSK? That is RB upon log base to M. Bandwidth is RB upon log base to M. So bandwidth efficiency is RB upon bandwidth, that is log base to M. Okay. So bandwidth efficiency is log base to M. Okay. This is fine. Now, what is the second one? M-ary PSK are spectrally inefficient. M-ary FSK is spectrally efficient. So this is a wrong statement, because M-ary FSK, as bandwidth increases, as M increases, bandwidth increases. So M-ary FSK is not bandwidth efficient. Okay, so this is wrong. Second one is wrong. Third one, the bandwidth efficiency of M-ary orthogonal FSK increases as M increases. This is wrong. The bandwidth efficiency of M-ary orthogonal FSK decreases as M decreases. So this is correct, right? Now what about M-ary FSK? The bandwidth of M-ary FSK okay, the bandwidth of M-ary FSK, what is the bandwidth? So we can see that the bandwidth is M minus 1 RS by 2 plus RS. Okay, can be written as M minus 1 into RB upon log base to M Okay, is this fine? Okay, so we can see that the bandwidth of M-ary FSK is this. Now what is the efficiency? Bandwidth efficiency, the efficiency is bit rate upon bandwidth. This will come out to be bit rate upon bandwidth. Bandwidth is M minus 1 into RB upon okay, so we can see that the RB will cancel and we can see this will come out to be log base to M divided by M minus 1 plus 1. So we can see as M increases, the bandwidth efficiency decreases because M is in the denominator, log base to M is in the numerator. Okay, so as M increases, log base to M increases slowly, but capital M increases linearly, fast. So as M increases, this term reduces. Okay, this term reduces. So we can see that as M increases, the efficiency decreases. Okay, so obviously we can see this one. Okay, as M increases, efficiency decreases. So the bandwidth efficiency of the M-ary FSK decreases as M increases. So very beautiful question. Answer is A and D. I hope all of you are able to do it. Let's move on. Is this clear? Okay. Now, two independent random variable x and y are uniform distributed in the interval -2 to 2. Okay. Two independent random variable x and y are uniformly distributed -2 to 2. The probability that maxima of this is greater than equal to 1. So what is the answer? So we can see that the joint PDF will be so this is from -2 to 2 distributed, so it will be 1 by 4 and 1 by 4 -2 x and y okay, so -2 2. Okay, now we have to find out that maxima of x and y is greater than equal to 1. We have to find out the probability that maxima of x and y is greater than equal to 1. So maxima is greater than equal to 1 means we can say it is 1 minus probability maxima is less than equal to 1. So maxima is less than 1 means both should be less than 1. So 1 minus probability x is less than equal to 1, y is less than equal. So we can see that this will come out to be 1 minus 1 by 6 integration, or we can say it is the integration of -2 1 1 PDF integration dx dy. PDF is a constant value, that is 1 by 16. Okay, how many of you are able to do this? I think no one is able to do any question. Okay, great. This was a simple one. I think many would have done this question easily. Okay, is this clear to all of you? Please check. Okay, is it done? Okay, let's move on. The ratio of bandwidth efficiency of this and this, so this can be done very easily. We can see that the bandwidth efficiency of M-ary PSK is log base to M, right? Bandwidth efficiency of M-ary FSK is log base to M divided by this, M minus 1 by 2 plus 1. Okay, so we have to find out the ratio of this. It will come out to be M minus 1 by 2 plus 1, that is so for 32 we have to find out, so this will come out to be 32 minus 1 by 2 plus 1, that is 31 by 2 plus 1, that is 15.5 plus 1, that is 16.5. Okay, so we can see that the answer can be 16. Please check all of you are able to do it. Okay, all of you are able to do it? नहीं, ये आएगा ना? एक बार चेक करिए, is this clear to all of you? Bandwidth efficiency clear है? Now bandwidth of M-ary FSK is also clear to all of you? Okay, so let's move on. Okay, now the signal is this, sampled at this using the ideal sampler, passed to the ideal low pass filter, cutoff frequency, the output of the filter is no. I will not do this question because this is a signal system question. Now, the source generates a alphabet with n equiprobable symbols. N equiprobable symbols. If a source encoder decreases the probability of half of the symbols by a small amount, and increases by the same for the rest of the symbols. Which of the following statement is or are correct considering the case before and after the encoder? So initially they were of equal probability. So we had maximum entropy. We had maximum entropy. Which of the following statement is or are correct considering the case before and after the encoder? Okay. Now source entropy was maximum before the encoder. Okay. The source entropy was maximum before the encoder. This is correct because initially it was maximum because they were of equal probability. The source entropy was minimum before the encoder. The source entropy will increase after the encoder. No. So if we use this type of encoder, the source entropy will decrease after the encoder. Okay. The source entropy will decrease because the maximum entropy is when we have equiprobability case. Now when the probability of the symbols increases and decreases, so entropy decreases finally, right? Okay, I hope all of you are able to do it. Okay, now let's see this question. The DSB full carrier amplitude modulated wave transmission, the sideband power, PSB represents the sideband power and PC represents the carrier power. On changing the modulation index to K-mu, where mu is the modulation index of the standard DSBFC, the ratio of the sideband power to the carrier power increases by the factor of 4. What is the value of K? Okay. So we can say that the DSB full carrier, we have to talk about, we have to take the modulation index case, that is A 1 plus mu m cap t cos omega ct. Okay. So we can say that the carrier power is A, carrier term is A cos omega ct. We can see that the carrier power is A square by 2 and the sideband power is A square 2 square pm cap into 1 by 2. Okay. Now we have to talk about the sideband power to the carrier power. The ratio will be mu square and pm cap. Okay. Now obviously when this is k times, so it is k square mu square pm cap. Now the ratio becomes 4 times. The ratio becomes 4 times, increases by the factor of 4. So the ratio will become 4 times when k is equals to 2. When k is equals to 2, the ratio will become 4 times. Is this clear to all of you? Are you able to do it? Perfect. Let's move on. Simple one. Okay. 5 message band limited to these frequencies, okay, respectively are to be multiplexed using time division multiplexing. Okay. The minimum bandwidth required is, so obviously you are using time division multiplexing. So yeah, this is a what we can say incomplete question, because in time division multiplexing we need to know the number of bits per sample, We can know, we know the sampling frequency is 3 kilohertz, 1 kilohertz, 4 kilohertz, 8 kilohertz, 1.5 kilohertz, but we don't know what is the number of bits per sample. So obviously we can do it. So this is incomplete one. Okay. Let's do this question. The binary source generate the symbols plus minus 1, okay, which are transmitted over the noisy channel. The probability of transmitting 1 is 2 by 3. If the received signal is SI plus noise and not represent the uniformly distributed noise, we have to find out the probability of error. So this is a very simple one. Here the conditional probabilities is given, that is the conditional probability of the received signal when S1 is sent, conditional probability of the received signal when S2 is sent, minus 0.5 to 1.5, okay, minus 1.5 to 0.5, okay. Okay, so we can see that what are the height, what are the values of this. So the value is 1 by 2, the value is 1 by 2. Okay, now for map rule we need to multiply with the probability also. So PS1 into the PDF of R given S1, PS2 into PDF of R given S. So this is minus 0.5, okay, minus 1.5 to 0.5, and this is multiplied by PS2. So now I don't know what is S1 and S2. So they should have given this. What is S1? So I think let's take this is your S1. S1 and S2 is given, right? S1 or S minus 1 should be given. So S of minus, let's take it like this. S2 is S minus 1. S2 is minus 1. Okay. So this will get multiplied by 1 by 3 because 1 ka probability 2 by 3 है. So this will have the probability of 1 by 3. So minus 1.5, this is 0.5, height is 1 by 6, and obviously the second one minus 0.5 to 1.5, height is 1 by 3, 1 by 1, 2 by 3 and 1 by 3 multiplied by 1 by, right? This will be 1 by 3. So obviously we can see that as per the ML rule or the map rule, we can see that this will be the threshold value. On the right side we will decide S1, that is plus 1. On the left side we will decide minus 1. Okay, and we can see that this is the probability of error. Okay, so we have to find out the probability of error. Yes. So the probability of error is the area of the shaded part. Probability of error is 1 by 6 into 1, that is 1 by. How many of you are able to do it? This was a simple one. This type of question is very famous in GATE exam. Okay, is this done? Is this clear to all of you? Okay, the channel capacity of the noiseless channel is maximum. Okay, so what is the maximum value? So we know that this is the noiseless channel. The information is the entropy of X or the entropy of Y. Now, since all are equiprobable, yeah. So we know that the channel capacity is maxima of the information. We take equiprobable case. So we can say that the channel capacity is log base to 5. Okay, the equiprobable entropy is log base to number of the points. Okay, the number of random variables. Okay, so this is also a very simple one. Okay, so consider a continuous time White's and stationary random process where the mean and autocorrelation is to be found. The autocorrelation is given. The autocorrelation is like this. So here we can say it is 4, then it is 2, 2 and minus 2. Like this we have the autocorrelation. So we can see that what is the mean square value? Is the autocorrelation at 0, that is 4. It is the autocorrelation at 0, that is 4. So this is fine, I think. Now, so this is wrong. We have to find out these two values. Let's try to get it. So we have to find out the expectation of x1 square, x1 plus x2 plus x3 whole square. So this will come out to be x1 square, x2 square, x3 square, x1 x2, x1 x3, x2 x3. Is this fine? Yes. So we can see that the values will be x1 square expectation, x2 square expectation, x3 square expectation. Now 2 times. Now x1 x2 expectation means the autocorrelation at 1. x1 x3 means 2 times autocorrelation at 2, and last is 2 times autocorrelation at 1. And what are these values? These are autocorrelation at 0. So these 3 are autocorrelation at 0. So what are the values? So we can see the autocorrelation 4, 4 and 4. RXX1 means you can see the value at 3. So 2 into 3. RXX2 is 2, and 2 into 2 RXX1 means 2 RXX1 means again 3. This is 15 plus 6 plus 4 plus 6. 10, 26 and 6. 32. Into 3, 6 and 6, 12, 12 and 4, 16, 6, 32 आ रहा है एक बार देखना. 32 आ रहा है, ये तो एक बार चेक करना, 32 आ रहा है, 28 एंड 81 तो नहीं आ रहा है, एक बार चेक करिए, काइंडली चेक ऑल ऑफ यू। तो दिस विल बी x1 square, x2 square, x3 square, then 2 times of x1 x2, 2 times of x1 x3, 2 times of x2 x3. So this is rxx0, 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 this is rxx1, rxx2 and rxx1. So rxx1 we can say this will be the mid value, that is 3. Please check, all of you are able to do it. So the value is 32, neither 28 and not 81. Okay, is this clear to all of you? Okay. Let's try to do this one also. The noise signal with PSD, it is given to us, is applied to the ideal differentiator. Determine the RMS value of the output noise signal, RMS value, root mean square value. We can see that the power spectral density of the output will be HF magnitude square into 10 to power minus 9 4 pi square f square. Okay, but only from, this is in kilohertz, right? So minus 2 into 10 to power 3 kilohertz to 2 into 10 to power 3 kilohertz. So what is the power of the output? Power of the output is, integrate this, power minus 4 pi square f square, integrate from minus 2 into 10 to power 3 into 10 to power 3. We'll integrate this. So this is integration of f square. It will be, it's an even function, so it will be f cube by 3, so 1 by 3 f cube 8 into 10 to power 9 power 9. Just check all the values are correct. This is in kilohertz, right? So this much kilohertz. So this much kilohertz means 10 to power 6. Okay, kilohertz means 10 to power 6. So the cube is 8 into 10 to power 18. So we'll multiply this. So 4 into pi square multiplied by 2 multiplied by 16 multiplied by 1 by 3. This will come out to be 421 into 10 to power 9. This is the output power. But we need RMS value. So RMS value is under root of power. This will come out to be 64.89 10 to power 4. Yeah. So this is the correct answer. Please check all of you are able to do it or not. 28 आ रहा है क्या? मैंने गलती करी क्या? कैलकुलेशन मिस्टेक करी क्या? 4 4 4, ये तीनों तो 4 हो जाएंगे. 4 प्लस 4 प्लस 4, ओ 12 होता है. 4 प्लस 4 प्लस 4 सॉरी फॉर द ब्लंडर कैलकुलेशन मिस्टेक, काफी गंदी कैलकुलेशन मिस्टेक हो गई. Okay, is this clear to all of you? All of you are able to do it? Okay, is this done? Okay. So thank you dear students. We'll continue from this point and we'll do more questions on our Hindi channel at 9:30 on Mahabhyas. Thank you. Bye bye and take care.